This is another version of the molar mass equation. This one uses a rho in it. Now, a rho is the same thing as a density unit. A lot of people will use D, but in our class we're using the rho. It's that Greek rho. It's not pressure. I know it's kind of confusing. Kind of looks like it has a P in it already, and then this kind of looks like a P, but it's not. It's a rho. So we solve this for m. Like, I'm just letting you know, you sometimes have to solve for this or sometimes have to solve for this. You can solve for the other stuff, but most of the time it's one or the other. If you were solving for the m, then you would have the rho, and you would be multiplying both sides times this RT. Not RT over RT, just RT and RT. So those would cancel. And then you're going to divide both sides by the P. So the other equation is rho times R times T over capital P. So it just depends on what you're needing. This is the same equation like I was saying, it's just solved for M. So the quick question is, how do we get from PV equals nRT to that density equation? Well, density is mass in a certain amount of volume, all right? Now, we know originally that PV equals nRT, and we also know that our molar mass is equal to mass over moles. So if we solve for moles, first of all, the way I'm going to do that is I'm going to multiply both sides by n. And I'll have m times m. And then I'm going to divide both sides by this term right here. So now I have something that I can substitute in right there. N is equal to mass over m. So now I have P times V equals mass times m times RT. Now, what I'm going to do is kind of rearrange these terms. What I want is I want to be able to, first of all, get this molar mass up on the other side. So I'm going to get rid of it being on the bottom by multiplying both sides by the big molar mass term. So that gives me molar mass times P times V equals m times R times T. And then density is actually mass over volume. And I have mass here, and I can divide, and I can get my volume over there. So I have molar mass times P is equal to this term right here being density times RT. And then depending on where you want to go with that equation, you can either solve it for the density, which is the MP over the RT, because you're just dividing both sides by RT. Or you can solve it for M by dividing everything by the P. So I was just letting you know how you get to these two equations. I know it's a bit of math there. If you just want to write them down, that's cool too.